In this video, I'll explain vSphere 6 high availability. We'll take a look at the architecture of HA and dive deep into some of the details of how heartbeats work and host isolation works and all of these fundamental concepts of HA. Now, vSphere high availability is used to recover virtual machines in the event of some failure, like a host failure or a virtual machine level failure. It does not provide 100% uptime. If you have an HA event, virtual machines will fail and then they'll come back. So in the event of a host failure, your virtual machines will go down and then they'll get booted up on some other host in that cluster. You can use HA to protect from a host failure or a failure at the virtual machine level. HA can also provide you with admission control, and admission control is used to ensure that there's sufficient resources to tolerate failures. HA does not utilize vMotion. That's one of the common misconceptions about high availability. It doesn't utilize vMotion in any way. vMotion is used to take a running virtual machine and move it from one host to another. With HA, your virtual machines are not running when an HA event occurs. They have failed, and they'll then boot up on some other host. And shared storage is required for high availability to operate. So, really quickly, before we get into the specifics of HA, let's talk about what a host cluster is. A cluster is just a group of ESXi hosts that have been associated with each other for some purpose. Maybe that purpose is HA. We want virtual machines to reboot on other hosts if one host fails. Maybe it's DRS, where we want automated load balancing across our hosts. Or maybe it's vSAN, where we want to take the local storage of ESXi hosts and use it to create a shared data store. Okay, so let's talk about the basics of how high availability operates. Here we see 4 ESXi hosts that have been grouped together as an HA cluster. And let's assume that ESXi01 fails. Now when this happens, VM1 is going to fail right along with that host. And then the virtual machine will reboot on another host because notice on the bottom that virtual machine's files are still intact on some shared storage. So another ESXi host can access those files on shared storage and boot up virtual machine 1. That's how high availability works. Now there's a lot that goes into actually making that happen. So let's take a look at the underlying architecture of high availability. The first thing we need is a management network. So here we see VM kernel ports on each host that are marked for management traffic. These are the VM kernel ports that will carry those high availability heartbeats between these hosts. So that's the first requirement, is we have to have a management network in common between all the ESXi hosts in my cluster. We also have to group together these hosts as a cluster and enable high availability. And once we do that, an election is going to occur. And one of these hosts is going to become the master, and the rest of the hosts will become the slave. Now my cluster has been established, HA has been enabled, and my hosts have elected a master, and all of the other hosts have become slaves. What happens now is the fault domain manager runs on each of these ESXi hosts. And the fault domain manager of the master communicates with vCenter to learn about the topology of this HA cluster. So the fault domain manager is actually the component of HA that provides a lot of the intelligence at this point. And it also is going to facilitate the heart beating mechanism that's responsible for HA. So here's how our heartbeats work. The master sends heartbeats to the slaves. So here's how heartbeats work. The master is going to send heartbeats to all of the slaves, and all of the slaves are going to send heartbeats to the master. That way the master is aware of any of the slaves that may have failed, and all of the slaves are aware if the master fails. Now, what happens if we lose vCenter? What happens if the vCenter server blows up? HA continues to operate even without vCenter. We need vCenter in order to configure HA, but we don't need vCenter for HA to operate. So the fault domain manager will continue to keep high availability running even in the absence of vCenter. Now, one of the important design elements of high availability is to create redundant heartbeat networks. Right, so let's take a look here. We see the master that's sending heartbeats to all the slaves, and all the slaves are sending heartbeats to the master, and then something happens, and our management network connection to host ESXi04 is broken. So now the master is no longer getting heartbeats from that slave. And this could result in the master thinking that that slave has failed, when in reality, it's simply a management network problem that's occurred, and that host is still up and running, and the virtual machines on that host are still running. A good way to prevent this is to create a redundant heartbeat network. And this is a best practice with HA. So what we've done is we've created an additional VM kernel port on each host that's marked for management traffic. And we've ensured that all of the hosts have one of these secondary heartbeat VM kernel ports marked for management, and that they're all able to communicate with each other. And preferably, they're able to communicate over a completely separate physical network, so that a failure of the physical network that interconnects the first management VM kernel ports won't affect the other management VM kernel ports. Now, this is an important design best practice that you should always follow when you enable high availability.